Hey everybody, today we'll talk about a concept called transfer learning and continue our discussion about augmentation. And I'll show you a technique where you can use a data generator and load images from file or a directory. And then we will use the ImageNet model that's already been created. This is a common model that has a lot of different layers, and we'll touch on that. And then you can modify the ImageNet model and for your custom application. And the application today I'm going to be doing is kind of interesting. I had a request from a colleague or partner that wanted to look at the behavior of cattle and wanted to know if a cow was standing or laying down in the field or at the feedlot. So I have a simple example of how to do that. And so that's what I have planned for this section. To start out, I wanted to show you, I've got a little snippet of code that I've loaded onto our class structure. And this is pretty interesting in that you can download a module called the Bing Image Downloader. You can search for that. And then you import that module, and then you create a query list. Here's your query list. And it will go and search on Bing for those images, and you can save them off to a directory. And for example, I'll call this one cow standing. And let me show you what the results of this looks like. Here's my images of cows standing. So it automatically goes off and searches the web, returns the images into a file of cows. Now, okay, well, here's not a cow standing, but a steak. So you need to curate these. I could see how that could be described as a cow standing, but this is a way for you to create a database of images very quickly, and it's a couple lines of code. So I'll post this code so that you can use it. For today's lecture, I've created those directories, one for cow standing and one for cow laying. And let me go ahead and just show that as well. Go back up here, and cow standing is where I was at. And I've got another data set called cow laying. And you can see here, now this one's a problem image because you have a problem because it has two cows that are standing as opposed to laying down. So that's a real world problem, is that we'll have to kind of parse through the data and remove the data that is not a good training set. And that's what we'll do today, is to create a model for these two directories. So to start out with, I've loaded in a bunch of modules, the classes that we'll use, and these are kind of the standard ones that we've been using. The ones that are not so standard is this MobileNet model, and you can see that there's a function called MobileNet, and then the weights are called ImageNet. And this particular function, what it does is creates the base model, and it has a way to basically remove the final output layer. And so they think of it from bottom to top. So the last top layer is the final output, and I've said don't include that, and then we're going to add functionality to the model to create a few more layers to the existing model. And then I've decided to make the image shape 128 pixels, and these are RGB images, so there's 3 channels. All right, so let's just load everything up to make sure everything's working. And now I've loaded up the base model, and here's a nice little function that shows you the summary of a model, and you can use this for any model. And let's go off and look at that. So here is the complexity of this ImageNet or MobileNet model. So you can see that it starts off with an input layer, does some zero padding, and then it has a convolutional 2D layer, and just keeps building. Here's a term called batch normalization that we haven't really talked much about. Basically, you use this to normalize your data between layers. In that, the normalization problem is if you have data that with really high values and data with really small values, it can create problems in your gradient descent. So normalization is a way to make sure that the data ranges over the same values, let's say from -1 to 1. And normalization is a classic technique that's used to be able to take data and from one set, if you've acquired it one way and you've acquired it in a second method, to ensure that has similar characteristics. For example, it's zero mean, and it ranges over 1 standard deviation. So just a technique to be able to ensure that your data is normalized between different layers. This one's kind of interesting, this depth-wise convolution 2D. We've talked about really spatial convolutional filters. This one is looking depth-wise within the channels, and we have not used that technique. But there's, most of this of things that we have talked about, the rectified linear unit and so forth. So what I'm going to do is, notice this thing is a very deep neural network. I'm going to take this deep neural network and I'm going to add to it. And how I do that is I have create a sequential model, and then I take the base model, and what I did is I flattened the output. And so the last output here has 1024 as its output. And so I created a dense layer with the same number of nodes or units. And then notice I used regularization, dropout function here, and then just a second layer with 1024, dense layer with 1024 nodes, and so forth. Now, I did something kind of interesting here. I used categorical output with using the softmax with 2 outputs. It's kind of like a binary output, but this will give a probability of each one of those binary outputs. So I use softmax on the output with only 2 categories, 2 classifications, a cow standing and a cow laying. Those are going to be the 2. So if I ran a model of this, we can see that, okay, here's our base model. And look, we've got, what is that, 3 million parameters, and then we're flattening that, and so we end up with 21 million parameters, weights and biases that we will be adjusting. So now the ImageNet is famous for, I think it was 2016 or 2017, it won the top competition with the highest accuracy to identify 1,000 different images. So really it's geared towards looking at images and classifying images. So the 1,000 classifications from dogs, cats, people, long list of animals. I think it even has teddy bears and polar bears and regular bears, brown bears. So we're going to build upon that network and be able to tell if a cow is standing or laying. Now what's interesting, right, since it's already kind of has 1,000 different classifications, that the model weights are kind of tuned to looking at and classifying, and in the ImageNet there's a large number of animals that are classified, so that's why I chose it. So that's a little background on MobileNet or ImageNet model. Okay, so an important thing here that we're trying to I'm going to show you is that you can use something called an image data generator. And the idea behind an image data generator is that you can take your we've covered this already, we take your data, and if you have a small data set, I think I only have about 180 images, well actually here it is, 181 images in the 2 classes. So do not have a large data set, and what the image data generator does is it augments or modifies the images to create new images so that we have a larger database to be able to train against. So I've got zoom, a shear range, which means you can kind of think of the image shearing, the top part and the bottom part moving slightly, and then rotation, some rotation, and then there's an important feature here called pre-processing, and you have to include that for the ImageNet. We want to take our new images and we want to pre-process them exactly the way the images were for the ImageNet model. And the way they did that is they ranged the value over -1 to 1. So it wasn't 0 to 1, like a lot of the data we've looked at. It's -1 to 1. And so there's a pre-processing function that basically casts all of the images into the same format that MobileNet used. Okay, so that's what that line does. I've included a line of code here when you go through the code that if you don't want to do the augmentation, you can compare the results. So there you have it. And then here you'll need to specify your user path. I have kind of a long user path and data sets, and then I have a trained data set. I'll quickly go back over this. What happens is the default setting, the way that this flow from the directory works is it looks for a data set, and then it assumes that the data set, for example, train, has whatever classifications are in the data set. So I've divided my data into one group called train. We're going to train on that, and then we're going to then show test data that the model has never seen before to see how accurate the model is, and I called that directory test. And inside of test, if we go back up one, inside of test, you can see that I have the same data structure. And so that's the idea behind using this data generator to collect data from file and then to be able to augment it and then train your model. So that's the idea that we're doing today. So instantiated the data generator called train data gen, and then I used this method here called flow from directory, and I give it the file path and the target size of the images, the type of images, they're RGB. That size we'll talk about in a little bit, and then seed in the class mode is categorical. It's categorical because I use softmax as the output. Even though I have a binary output, I'm using softmax so I can get a probability for each one of my outputs. So that's what I did today. Now if you set this shuffle to false, it collects the data from the directory in the same way every time. I'm shuffling it so that when it loads up a batch of 16 images out of my 181 images, it'll shuffle those data and shuffle the data so that we can do a good job training with the model. Okay, so that's the idea behind using this data generator. Is I set up the parameters here, and then now I can use, as I acquire the batch of images from file, I can apply these different parameters to that batch of 16 images. And so it randomly does for example, randomly does a zoom between plus and minus 0.15. It randomly does a rotation between -5 and 5 degrees. And if you want to see the details on each of these functions, you do Shift Tab, place your cursor right there after the first paren, and then it shows you and gives you the details for each one of those functions. Okay, so what I did is then, okay, let's just go ahead and run this. It goes off and gets the data from the train directory, datasets train, and then it loads all that data in. So it loaded in 181 images, and in train there is one directory called, or folder called cow laying, and another called cow standing, and I want to tell the difference between those two. So I did a little bit of Python tricks here to be able to show you the data, so I can load in the data and show you the data that the train generator is actually picking. So we're using a batch of 16, so it loads in 16 random images and then displays them. So let's run this one time, so that it goes off and takes the images and displays them. Now notice I've got, since I used that automatic image locator through Bing, it goes off and returns a lot of odd images. Like this is a picture of a cow standing with a picture frame. Here's a pillow. Oh my gosh. So there's all kinds of odd different things inside of this image, and what you should do is really kind of curate these. So for example, this one is saying that the animal's laying. Okay, they're laying there. This one's laying, and so we would want to go through and check these. So you can see that it's got a kind of a random group here of standing and laying images. Okay, so let's go off and if I run this again, this next operator will generate the next X image for the batch. We'll give you 16 new images. So let's do that again and see what other odd things that we have in here. So here's some other interest. This is Angus Scott from AC/DC. He's laying down. Well, we'll have to remove that image if we were doing this for a full project. But you can see that it's a fast way to get data, but you'll have to curate your data to ensure that it's matching what you're hoping to train for. All right, in any event, let's go ahead and train this model using the data that we've collected and see what kind of results that we get. All right, here's just kind of a tip. I like to see what keys are a part of the train generator. To do that, you can use this _dictionary _.keys, and it tells you all the things here. For example, if I want to pull out the class indices, which are the directory folder names, you can see that it's exactly as I've described, and it's saying cow laying is a 0 and cow standing is a 1 as our indices. And then if I want to show the number of samples I have in is 181 in this case. All right, here's my compile. So I'm going to use the Atom optimizer, and I'm doing categorical cross entropy. I'm using the softmax as the output, and it'll give me the probability of a standing or a laying cow. And I'm only here's an important thing here to cover, is I'm only going to use 5 epochs because we don't want to have a long video here. You might use and track the training and the loss and the accuracy to be able to understand if you're overfitting. My previous model, I just ran this, and it ran for 10 epochs. And it's an important thing to point out that an epoch is one pass through all of the training samples. So it's one pass through my 181 samples. And then we have this concept of a batch, because if we loaded up the whole entire database, it would take all the memory that we had, all the RAM that we had, and the compute would take a long time to go through all of those. So we break it up into batches. And so we bring those batches as a subset of the samples, and loading all the samples is just really may take up too much memory. But ultimately, we load all the batches and go through all of them in one epoch. So that's the idea here. Here's the loss, which is really, you can think of how the weights changed, the net change in all of the weights and biases for the whole neural net. So you can see that it's converging, that we're having a difference between 0.77 to 0.16 on this last iteration over the epoch. And then the accuracy is the accuracy of the predictions for the training model itself. Meaning, if we said it was Cal Lang, it was in the Cal Lang directory, what does the model predict? So you can see that after 10 epochs here, I'm getting 0.96 accuracy over those 181 images. All right, as you know, we can overfit that based on our discussions from the past. I'm not going to talk a lot about overfitting for this model. I'm just introducing how to create a transfer learning model, take advantage of the MobileNet model and then add to it. So let's go ahead and run this for 5 epochs. And it takes a while to run, so we're going to go through that, and it's crunching through. We can see that we start out with a real high accuracy. It's probably going to go down for the next epoch, and we can see how long that this takes. It doesn't take that long to run through this. So let's let that continue to run, and we'll come back and look at that. So the next thing I want to do is I'm going to do something a little bit unusual. This isn't covered in your Deep Learning Chapter 5, which we're working from, but it's another way to kind of look at your data. So what I did is I have the data set, and now is my new set of data. All right, let me go back over here. So we're training on this data set, Cal Lang, Cal Standing, and then I want to test it against a never seen before set of images. And so here is my other set of databases, and it's a little bit smaller, but it's still quite a few images. Now, typical systems you'll build will have thousands of images. So the problem with this data set is fairly small. It's only a couple hundred images that we've used for training, and then I have I think it's maybe 100 to 150 images that I'm going to test it against. And even in this data set, there are problems. I bet this image is going to be challenging because the animal looks like it's standing, has its legs out, but it's laying on the ground. So that's kind of interesting, right? So we're going to test against this test data set. That was the laying animals. Here's the standing animals. Oh, notice, see, I've got some cartoons in here, some things like that as well. So that's kind of interesting. And here's an animal that looks like is just kneeling and getting up. So is that standing or is that laying? So that's interesting to look at. So let's go back, and we're on our 5th level here, and kind of 97% after 5 iterations through the training data set. So now what I want to do is I'm going to take the test data set, and I want to take the Cal Lang folder, and I create a path to that, and then I do a little processing here. And what I want to do is I want to look at each image and say, okay, it's supposed to be Cal Lang, and then it predicts this output here, this text here is what the prediction was. So I can quickly go through my images here in the test data set to see, you can see as it's doing it here, it's doing the predictions. And so all of these are the Cal Lang folder, and so we got a 96% on the new test images out of 89 images. So that's pretty darn good. So let's do, there's another set, Cal Standing. Okay, and we run this code for the test images. So the model has never seen these test images before, and it's going to run through here, and we can already see it's kind of mislabeling some of these. So this is not going to have as high a accuracy as 63.5%. So this is probably an example. This is an example of overfitting because our model says that we've got a 97% accuracy, and we know for one of our test folders, the Cal Standing, that we're only getting about 64%. Now, the baseline for this is, I guess, the original laying was the baseline for this. We had 52, and for our other test set we had about 90 images. So we can see that we've got a pretty good accuracy here, that we got 63, but we probably could do more augmentation and work on our model to create a better model. Okay, so that's what I had planned for today, was to overview how you would use an existing model, MobileNet, or it's also called ImageNet. You load in that model and all of its parameters and weights, and then you can add on to it by using the sequential add function, and then taking, there's a function to be able to create the baseline model and add to it. So let me scan back up here so we can review that. So we add the base model. We created the base model above, first removed the output section, and then added to the model by adding these different layers. So there's an introduction of how to use transfer learning, and a little bit more about how to use augmentation and loading images from file, and a little hint on how to find data using Bing, using the Bing image downloader. I'll post this code so you can use it in your examples. All right, until next time.